As mentioned, I have almost 15 years of experience and worked in multiple companies, persistent, Street. I spent almost 9 years in LinkedIn, and actually 9+ years, out of which around 6 to 7 years in Kafka. But to be clear, I'm not a Kafka developer. In the entire my career, I worked as a SRE or DevOps. So just to be clear. Ghazanfar?
I'm with Confluent now. I was with Nutanix for about 5 years, and I worked on something called IDF when I was with Nutanix. It's slightly similar to Druid, but not exactly. And now I'm with Confluent and work with Druid. Yeah.
Yeah, so for those who don't know about Confluent, Confluent is a leading data streaming platform, provides solutions around Kafka based solutions. Next slide. Okay, so today we'll discuss the problem around the observability, observability at Confluent. So just a high level overview. Then we talk about ingesting data. We talk about some numbers. The deployment, the Druid deployment in Confluent. Then recently we did, we had a lot of issues with our Druid clusters, and we did some performance tuning around the segment. So we'll talk about that, and then the last takeaways and success. So yeah, so when we say Confluent provides Kafka-based solution, it's not customer. They are not just looking for the Kafka-based solution. They also want the metrics around the products they are using, and products can be varying, different kinds of products, and they kind of want all the metrics to have some kind of visibility. And the other problem is, yeah, and since we cater to a lot of customers, most of the customers they won't stick to we can't expect that they'll stick to single platform, right, to ingest the metrics. So it can be Datadog, PagerDuty, Grafana, anything. So we needed to solve that problem. Next. So yeah, so it's just a snippet from the observability primer. So it's observability is it's a kind of gathering metrics and get the visibility so that we can troubleshoot the system as easy as possible without getting into the core of the application, knowing what application is doing. That may be we may have to dig into that, but that's a later part if we don't get anything from the metrics at all. Next. Yeah, so real world scenarios apart from our engineering life. These are some of the examples of observability. MID in your vehicle, your phone, battery, charge status, etc. Okay, so Confluent Kafka right now caters has around 70K clusters and increasing. We have on-prem as well as cloud Kafka clusters. So when I say on-prem, so some of our customers they wanted to host Confluent Kafka in their on-prem data centers instead of using native cloud solutions. Then we have customers who uses native cloud solutions via Confluent, and we collect ingest and index around 300 million metrics per second from both on-prem and cloud. The other challenge was to time to market, in a sense, support all the possible tools so that our metrics gets integrated to those tools, because customers can use any kind of tools like or UI or solutions like Datadog or PagerDuty, etc. And the other major important thing was to provide these metrics with very low latency. So many of their customers want those metrics within less than 2 minutes. Okay, so we actually analyzed few solutions like Pinot, GCP BigQuery. That's too expensive, and we also analyzed Druid along with these, and we found that Druid fits our criteria. And also one of the major reason was we have a Druid committer in Confluent. So it's a no-brainer to choose Druid because he's expert in that. So Druid provides provides scales horizontally very easily, as far as we have seen. It integrates with most of the ecosystem. In our case, it's Kafka and Grafana for our internal cases. And then it provides a very low latency throughput. Okay. So yeah, observability at Confluent. So we have Confluent Cloud tenants. So it's on cloud. So we have multiple cloud, AWS, Azure, GCP, where Confluent hosted their Kafka clusters. Then we have Confluent platform, which is on-prem. So these are on the customer end, on their data center. So what we do is we collect all these metrics via open telemetry and push it into we put it into Kafka. From there, Druid pulls those or ingest those to Druid system. And once it is stored, it caters to our customers via Confluent Metrics API. And it easily gets integrated with Datadog. So basically, we have customers where they configure their Datadog to query Metrics API. Similarly, we have Grafana clouds and other solutions. Other use cases for billing and data science. So in Confluent, billing team uses these metrics to calculate the bills for our customers. And then we have a data science who pulls these data to crunch number around usage and etc. Yeah, so we have one product called Health Plus, which is again a Confluent offering, which provides alerting and notifications where customers who don't want to use Datadog and other, they want to use Confluent's native alerting notification. So that is powered by Grafana. So Grafana pulls metrics from Druid and sends out the alerting events to Kafka. From their own Health Plus application takes care of sending notification and emails, etc. to the customer. Okay, so yeah, as I mentioned, in Confluent, Druid consumes from Kafka. So in Kafka, in production, we have a single topic with 360 partitions, and we get around, so that's a typo, we get around 5 million records per second. And for resiliency, we retain these events for a week so that if needed, we can re-ingest them. And yeah, so, and it provides a low latency solution. Generally, it's around 10 seconds. Yeah. Okay, so our Druid cluster. So we have two large Druid deployments, production ones. We have another few other clusters, but the big ones are these two large Druid deployments. And we have 70 terabyte and 100 terabyte of data respectively. And this is excluding the deep storage, S3. And from metrics, via metrics API, we get around 1,000 plus queries per second. And our average latency is 300 millisecond, and P95 is about 1 second. And so this is a real kind of near real time solution for our customers. So the metrics are available within a few seconds to query. Okay. Yeah, so as I mentioned, we get around 400 plus API requests per second to our metrics API. That gets translated to around 1,000 plus queries to Druid, queries per second. And right now, most of them is coming from the Prometheus deployments via customers. And also, as I mentioned, we Grafana also uses consumes these events and sends out alerting. And yeah, all these are we are using open telemetry standards. Okay, so the Druid architecture at Confluent components are almost same. No change as we have seen in the previous presentations. The only exception is we have indexer and middle manager. So we used to have middle managers for ingestion and compaction, but we faced issues, performance issues with that. And we experiment with indexers. And now, right now, our production cluster is running with indexers only for ingestion and middle manager for compaction. Similarly, we have multiple tier for historicals, hot, secondary, which is added, I think, last week. And then we have a default. For hot, we have a retention of, I think, 7 to 9 hours. And for default, it's 9 days. So hot is for to cater to our external customers. Default is for our internal use cases for billing and data science. And we have a secondary which we introduced recently with because earlier to that, hot was serving both our Confluent Cloud use case as well as on-prem use case where customer used to query. And we have seen performance issues there. So what we decided that we'll have another tier where we'll split the queries. So all the Confluent Cloud will go to hot, and the rest of the on-prem ones go to the secondary. So yeah, this is the kind of architecture which we have. So now will Ghazanfar will take over.
Does this work? Yeah. Hey, hi. So I'll continue from where Ratish left off. And this is our deployment. All our Druid is deployed on Kubernetes, and this is deployed on Amazon with Helm. And we use indexes for ingesting data from Kafka, as Ratish showed. So we have about 94 indexes, which ingest from Kafka and run about 190 tasks. And these have 3,000 plus CPUs in total. And we shifted to indexers from middle managers about a year ago, and they've been performing much better than middle managers have. We continue to use middle managers for compaction, and our queries are heavy in the recent, right? From now -5 to now -6, 7 is when we get our highest query load. That's like 70–80% of our load. So to avoid stuff changing at that time, what we do is we have our middle managers delay the compaction by about 3 hours. Yeah, so we continue to run middle managers and indexes. We also have historicals to serve our queries. And these are segregated into 3 different tiers based on different kinds of query loads. So we have one hot tier, which gets the most queries, and this directly serves customers. We also have a secondary tier, which has a different data set, which is tuned separately because the query pattern on that is different. The query pattern on that tends to query a larger amount of data, but fewer queries. We also have a cold tier, which holds data for 7 days and runs on cheaper machines. Our hot tier, actually our historicals together have, again, about 3,000 plus vCPUs. And we also have large memory, right? So about 8.5 TB of memory across historicals. This is main memory. We also use caches. We use 2 caches. One is the caffeine L1 caffeine cache, which runs along with historicals in the same pod. We also have a AWS mem cache, and the hit rate for this is between 30 to 70% on historicals. On indexers, you generally don't benefit by caches because it's real-time data. Every time you get a query, your data is different. We store all our data in S3 for up to a year. That comes to about 3.6 petabytes of data. So earlier, we actually wanted to store a lot more data in our historicals, but we couldn't do that because of cost limitations. Personally, I would like all of this data to be queryable, right? Because it helps support engineers, it helps your customer. But with Druid 27, there's a feature to directly query from deep storage. So pretty excited about that. But going by how Druid upgrades have been going for us, that's a long time. Yeah. So I've recently spent last 2 nights trying to upgrade Druid 24 to 25, and it has not been fun. Yeah. So about a month ago, we spent time trying to optimize our segment sizes. Our query, because we get more and more data, our query times would gradually get worse and worse. So at one point, you have to sit down and figure out a solution, right? So what we did is we started looking at our segments and how can we tune the size to get good performance, right? So after we did this activity, we saw over a 70% improvement in the average case, and sometimes the performance was as good as 70, 72%. So what did we do to get this? So first we changed our segment granularity. So segment granularity is, I personally don't really like this name because it looks like it has something to do with segments, but in fact it actually means time chunks within which Druid divides its data. So earlier we had segment granularities of 15 minutes and we went down to 10 minutes. So what happens is any query that you get within a time chunk will query all segments within that time chunk. So if you have a segment granularity of 1 hour, but you want to query data for 1 minute, you will still look at all segments of that 1 hour. Because our query pattern showed that most of our queries asked for data which was very short, right? We get a lot of queries, but they ask for very little amount of data. So we changed our segment granularity to 10 minutes. That effectively reduces like 33% of the data you read for every query. And this also gave much better, more performance than expected because things started fitting into the cache better. Apart from that, you also can look at your query granularity. Query granularity sets, you can ask data for every millisecond or for every second, right? But our queries followed a pattern where they asked for data with granularity of 1 minute. So there's no point in storing data with lower granularity. So optimizing this also helped. And segment handoff. Segment handoff is when an indexer or a middle manager reads data and builds a segment and hands it off to historicals, right? So this is pretty important because indexers right now hand over everything that they have. There's no way to hand off like a part of the data and continue serving queries on the other part, right? So what happens is when indexers hand off, your newer queries will now spread across historicals as well as indexes. So our query fanout becomes twice as much as what we generally see. So what we did is we measured our ingestion rate, how many metrics we get, and we tried to bring that as close as possible to segment granularity, right? So what we did is we changed our segment handoff time. So there are three configurations over here, right? So these three configurations govern when your segments get handed off. So what we did is we tuned these so that it's as close as possible to the segment granularity. And that makes sure that at least half the time you get good performance, right? Because all your queries will get served by indexes rather than half your queries going to indexes and historicals. Actually, it's not half. Your queries fan out to both indexes and historicals, and to avoid that, we try to bring segment handoff as close as possible to segment granularity. But unfortunately, this keeps changing because segment granularity is clock aligned, but segment handoff is not clock aligned. So what we see is now a 4-day pattern where every 4 days your queries are fast and then they suddenly become slow and then they keep getting fast. So that's something we live with because things have definitely gotten better after changing the segment granularity. And with change in segment granularity, we also have to look at compaction because compaction looks at all the data within one segment granularity and produces as many segments as you want. So we try to keep segments equal to the number of historical nodes we have. Actually, one minus so that with 2 replicas, it fits well into our historicals. Yeah, that's about it. So this was our result when after we deployed our segment granularity changes. We saw a very good improvement in our query latencies. Yeah, so that's mostly it, and I'll talk about some learnings, right? So ingestion scales very well. You get more data, you add more partitions to your Kafka, and you increase indexes. And this keeps doing well. It has worked very well for us till now. 94 indexes running 180 tasks, about 190 tasks. We plan to enable ingestion task replication soon, but that's a little later. And Kashav was just talking to me about a bug in indexer replication, indexer task replication. So I'm a little hesitant now. We'll probably have to look into that again. There is also a integration between Grafana and Druid. It's an open source integration. It's not very actively developed. There are a couple of people who look into it. So if you're looking for an open source project to contribute, that's a nice thing to look into. So this worked out well, and it helps our support engineers a lot. So after integrating Grafana with Druid, we've seen that there are always about 120, 130 support engineers who access this to help with their cases. And historical scale. Historicals are, I'm not sure if I like them or don't like them, but the thing is they have very high fan out. With very high fan out, what you get is work is distributed much better. Every historical does very little work. But the problem is if one historical is performing badly, your entire pipeline is performing badly. So your tail latency is increased. So sometimes when a single historical node degrades, what we see is all our queries are degrading because all our queries hit all our index, all our historicals. So historical scaling is something that you want to keep in mind. I'm not sure how you could do that better while keeping your latency within check. And lag has been a big problem for us because our query load is very sensitive to lag between now -5 to now -6 minutes. So that's where most of our queries come in. Yeah, we've been trying to solve this problem, but without much success. Restarting an overload makes things terrible. If an indexer goes down, it's even bad. For indexer going down, we've been trying to fix it by having ingestion task replication. So another problem is monitoring this whole pipeline which Ratish showed, right? You can't do that because this is the pipeline that lets you monitor it. So there's a circular dependency. How we do that is we have a hotel collector which sends data to Datadog directly. And the last part is because all of this is deployed in Kubernetes, and the Druid operator is not as stable as we would like it to be. So we are hesitant to use that in production. Yeah, so Kubernetes deployments take a lot of time. You have to babysit them. And because they generally, our historicals use local disks, okay? And Kubernetes deployments clean up your disks. So all historicals will have to reload segments. And when they reload segments, their latencies spike for reasons we don't know yet. Yeah, so running it on Kubernetes has a bunch of challenges. Yeah. Okay, so after doing all of this, our alerting and monitoring works pretty well. Our Grafana generates about 300 alerts by querying Druid data very frequently, which is used by over 100 support engineers daily. Another project which someone from another team was looking at is to look at the metric data within Druid and try to scale our cloud deployments, scale up or scale down our cloud deployments. But this is planned, and we've really not done this, so I wouldn't want to talk about it so much. So from customers, we get about 400 API requests per second. This is like your Prometheus. So someone has set up their Prometheus config to scrape metrics from Confluent Cloud. So we get about 400 requests per second, and this metrics API requests translate to multiple Druid requests. So this basically translates to about 1,000 queries to Druid per second, and this also integrates with Grafana Cloud and Datadog. And to give you a sense of the reliability, right? So Confluent's billing also runs on the metrics that are there in Druid right now. So if Druid is down, Confluent loses money. Right? So that's how reliable we want it to be. Yeah. Apart from that, I think that's the last slide. So I'll take some questions. And while I take questions, yeah, you have a promo code from Confluent Cloud. You'll get like $100 of free usage if you use that. Yeah. Any questions?
Yeah, hi.
Yeah, hi.
So you talked about reducing the segment size to serve queries faster, right?
Segment size, okay. Yeah.
So there is also this thing with Druid where they suggest, I think, a max number of, an optimal number of rows / memory per segment. How do you balance between those both?
So there the recommendation is to prioritize number of rows over batch size, unless your row is extremely large and it doesn't fit well into memory. So when we optimized our segments, it actually went a little over the recommended 700, but the performance improved. So those recommendations are probably general recommendations, and you have to optimize it based on your query pattern. Yeah, so you'll have to look at your query pattern and optimize for that.
Got it. Good.
Yeah.
I have a question related to the alerting slide. You showed that you use Grafana to query Druid and then send out the data to Kafka.
Can you go to the architecture slide?
The first one.
Back. No.
The first one.
The other one. Yeah.
You use Grafana to query Druid to send out alert.
Yeah. We use Grafana to query Druid, and based on some rules which are set up in Grafana, we send out alerts which go into Kafka.
Right. So the question is, the data source for Grafana is Druid. And you use Grafana Alert Manager or some other alert manager?
Grafana Alert Manager. We use Grafana's Alert Manager.
And your output contact point is Kafka.
Output contact point is Kafka Cloud, Confluent Cloud. So you can.
Is this a proprietary implementation or it's an open source implementation?
The part that you're talking about, I personally implemented it, and it's open source.
There is no documentation on this part.
This is pretty recent. This was implemented in January.
Is there a documentation on Grafana's website?
This is documented on Grafana's website. So you have to keep in mind that this is for Confluent's Kafka deployment, right? So because Confluent's Kafka deployment offers APIs through which you can publish, and Grafana uses that one.
So I'm more interested in using Grafana Alert Manager to publish those alerts data to any kind of cloud, not.
Yeah, if you're using Confluent Kafka, then you can use it out of the box. So you can go to Grafana's UI and set up the alerting to publish. This is your contact point. Your contact point will be Confluent Cloud Kafka. But if you're not using Confluent Cloud, you have to use a Kafka REST proxy.
We have our own Kafka platform.
Okay.
So we have our own Kafka platform. Can we use possibly that?
If you can set up your Kafka platform with Kafka REST proxy. Kafka REST proxy is an open source product offered by Confluent. If you can set up that with your Kafka, then you can use Grafana to publish to your Kafka using the Kafka REST proxy.
Okay. Thank you.
Yeah.
There are some questions online.
Yeah.
Some are open-ended, some are not. So we'll just see. There are about 5 questions. So the first question is, what is your data model and topology? Could you shed light on some sources, like how many data sources you have, etc.?
We have 3 data sources. Most of our data comes from Confluent Cloud. Right? Data that comes from Confluent Cloud goes into one topic. Actually, data that comes from Confluent Cloud goes into 2 topics. Most of the metrics in Confluent Cloud they don't have very high cardinality, but some metrics have very high cardinality, which are moved to their own data source. So two data sources from here, 1 data source from here. And total data stored in Druid for 1 week is about 70 TB across all of them.
Okay. Yeah, that was a question from Roland. Hope that was answered. We have another question from Vaibhav. What were the upgrade challenges in Helm and Kubernetes? Are you using help chart from the Druid repo? Were you able to achieve 0 downtime upgrade?
This time, So our downtime is measured by the queries being answerable and the lag being within 5 minutes. Okay, actually within 4 minutes something, right? We were able to achieve 0 downtime on queries. So none of our queries failed, but we did see an issue with lag. So sometimes our lag built up, which took about 10 minutes to catch up, and our SLO gets violated because we expect customers, we sell this to customers telling you can set up your monitoring and your pager duty on this, right? But what happens is if our lag is more than 5 minutes, and if your page comes 5 minutes late, that means our customers would have already lost some business or their system would have gone down.
Okay. Just maybe 3 more questions.
Yeah.
What is the cardinality of data? How many unique data points or time series? And can you just answer that first?
Yeah. So how many? So every minute we create about 325 million rows. So cardinality, I tried to actually fetch cardinality, but my query timed out because we have a short timeout. Yeah, I don't think I'll be able to answer your cardinality question.
Okay. Yeah, sorry for that, Roland. So we have 2 more questions. This is from Mangesh. What are the top 3 queries served? Like
the 27th thing I'm excited about is the ability to serve queries from deep storage, right? So right now our data is only queryable for the last 7 days. So any data that is after that is sitting in S3 is not queryable. Yeah, that's the part I was talking about. Was that the question?
No, it was more like what are the top 3 queries served? Like maybe in terms of volume, like what is the most frequent queries?
So our most frequent queries are by these, right? So our customers take Prometheus, they have their own Prometheus deployment, and they configure Prometheus to scrape from Confluent Metrics API every minute, right? So that's our largest share of queries. And these queries query for data, which is now -6 to now -7. And because of delays, this becomes now -6 to now -7 or now -5 to now -6. But that is where our majority of our queries come from.
Got it. Regarding the Druid strategy, can we confirm it was a Helm or the Druid operator?
We use Helm on production, but on non-productions we've used operator, and we are not confident about trying operator on production yet.
Yeah, it's a new thing.
Because it has restarted a couple of nodes in the middle of nowhere.
So again, clarification. Can you, if you can, tell us the number of data sources in Druid?
Number of data sources in Druid is 3 on production. 3.
Okay, cool. This is again the last question from Mangesh. How much pre-processing and post-processing is done to serve these queries?
Okay, that's a good question. So we have implemented our own pre-processors when ingesting into Druid, and these do very simple stuff, right? They take some string, do some splitting, and ingest into another column. The reason why we've implemented those on our own is for performance reasons, right? We could have definitely used some of the existing transformers that Druid offers to do it, but we choose not to do it because those perform worse than what our own implementations perform. It's very simple. It's a string.split, and yeah, pick one of those. Yeah.
Got it. Yeah, I think there are no more questions.